Friends, my name is Pawan. I am again with you to discuss about 10K magnets in MRI system. You must have heard about 4K systems and 10K systems in MRI machines. So the 10K technology was the older technologies in all the vendors. They were using the same technology 10 years back, and nowadays it's a zero boil off technology, and the term is called as 4K magnets. So before discussing about 4K magnets, I thought that it is better to discuss first about 10K magnets and 10K technology. So if you like my theoretical details, and basically friends, I like to discuss all the theoretical aspects by drawing all the things on the board or on the note copy or like text copies. I don't prefer to download the images and show and prepare very good colorful slides. So I prefer this method for knowledge sharing, learning and teaching. So if you like this method, please write in the comment box and give your feedbacks, and if you don't like it and I need to modify my methods, please give your inputs and valuable feedbacks. Okay, so let us start this. So in the right side of this presentation, you will see that I have made this chart like 300 Kelvin, 273 Kelvin, 80 Kelvin, 94K, 269 and all. So these are all Kelvin readings. Okay, so 0 Kelvin means minus 273 degree centigrade. 4 Kelvin means minus 269. Normally the helium temperature is this one, minus 269. See, you can see the liquid helium is 4 Kelvin, minus 269, and the formula with which you can convert is this one. So any Kelvin readings you can convert in degree centigrade using that formula. Okay, so let's go to the next slide. This is the basic. Actually I have prepared this presentation, and so that it will reduce our time, the drawing time. So 10K magnets, basically this magnet, I have tried to prepare one this vessel. You can see this vessel. Okay, and liquid helium is filled inside. You can see the liquid filled inside here. These are all liquid helium. Okay, and in this vessel you can see some gas clouds. Okay, so if we make, so before going to that main core topic of magnet, I am trying to make a little overview. So this is a kind of vessel. Suppose I have taken one vessel and some liquid is filled inside. So what will happen? This liquid is minus 269 degrees centigrade. So the cooling effect will come out from here. Okay, so we need to protect that. We need to stop this effect from going out. Okay, so let us see what else we can do in the next slides, and also pay attention to this scale also. Where is your room temperature? See in the Kelvin reading, this is your absolute zero. This is your helium temperature, minus 269 degrees centigrade. Okay, so next slide. Suppose this is the vessel. In the previous slide I explained, this is your, see, this is your vessel. Okay, this is your vessel. Helium is filled inside. Liquid helium minus 269 degree centigrade liquid is filled inside. Okay, and some gas clouds. So here I prepared one shielding. Shielding means to protect the heat. The outgoing heat will be stopped. This shielding here will stop, and the heat cannot transfer using this shield. Okay, so let us go in another slide. Here in another slide, one more shielding I have made. This is your this is your magnet. One by one I am adding the concepts, otherwise that will be difficult. If I'll go in direct MRI internal design, that will be difficult for you to understand. See, this is the magnet, and this is the main vessel. Inside there is a liquid, this red one is a liquid, and some gaseous clouds. Okay, so this vessel I protected with one shielding. Okay, this is 20 Kelvin shielding. Shielding means to protect the liquid heat, the liquid cooling from going out. Okay, and this is the 80 Kelvin shield. So two shields are stopping the liquid, the cooling from coming out. So this cooling effect will not come out. So helium, whatever helium cooling effect is there, it will be intact inside this vessel. So this is a vessel. Now there nothing, so far I have not discussed anything about magnet or nothing. I am just explaining about vessel. So this is red color diagram, this is one vessel. Okay, inside there is some liquid and some gaseous cloud, and outside the orange color you can see one shielding. This shielding is 20K shielding, and this one is 80 Kelvin shielding. Okay, two shieldings are there. And why these two shieldings? To stop the liquid effect from going out. So now next slide. In this slide you can see inside this is a liquid helium and gaseous helium. Okay, as you know, liquid helium is of 4 Kelvin minus 269 degree centigrade temperature. Outside this orange color is a 20 Kelvin shield, purple is 80 Kelvin shield. Now there is one more shield, outer vacuum shield, OVC. Some company, different vendors have different name. So you just understand the concept, outer vacuum shield. So whatever shields we have, 20 Kelvin shield, 80 Kelvin shield, we have introduced one more shield. This is outer vacuum shield, and this shield is protecting both the shields, this one and internal vessel. Okay, and there is a vacuum here in between. Here there is we are establishing a vacuum. Vacuum means we are taking the air out. Whatever air is in this area, in the red color diagram you can see, in the red color sketch, whatever air is there, I am taking it out. So this chamber is a vacuum chamber, and inside that there is a purple shield, then orange shield, and internal one is the vessel for liquid helium and some gaseous clouds. So clear? So now, after completing this 2-3 shieldings layers and all, I want to explain a brief little short introduction on the magnetic field and its effect on the current. How the current is proportional to the magnetic field. As you can see in this Biot-Savart law, it is clearly explained that magnetic field B is equal to mu 0 upon 4 pi ideal sin theta upon r square. So current, you can see current is proportional to the magnetic field in this formula. Whatever is the situation, if there is a solenoid coil and you are sending a current in a coil, definitely there will be a magnetic field. As you might have studied in your school days, Biot-Savart law is this is the L length of a conductor, and you are putting I current in that. At a certain distance r, you will feel a magnetic field. So wherever there is a current, definitely the effect will be, it will create an effect of magnetic field. Again, same diagram. So in this diagram, again I tried to draw the same diagram. I am repeating this again and again to make you better understand on this topic. So see, the internal one is liquid helium, minus 269 degrees centigrade. So that cooling effect will try to come out. Okay, but no, it is not possible because this orange color gentleman is sitting here, orange shield. This is 20K shield, and to make it more strong, to make the shielding more strong, there is one more shielding, this one, that is called 80 Kelvin shield. Okay, and to make further more strong, the outer one is called outer vacuum shield. Okay, and in between here, in this area, there is a vacuum. Okay, air out. So if there is a vacuum, so heat transfer from here to here, heat transfer is not possible. From here to here, heat cannot go out. Understood? So internal one is your liquid. Okay, then one more shielding, 20 Kelvin shielding, then 80 Kelvin shielding, and then there is a outer vacuum shield, and in between there is a vacuum. Okay, to take the air out. And now this is your arrangement. In the black color you can see here, okay, we have positioned your coil. Some niobium material is there inside, super fine material. So this winding is your magnet coil winding, and you inject a current inside, and that current will survive for a long duration. There will not be any loss. As per Ohm's law, V upon R is equal to I. If this magnet, this internal magnet coil, this coil is dipped inside the liquid, if there is a liquid here and this coil is dipped in that liquid, so what will happen? This coil will become super cooled. This black color coil will become super cooled. Okay, and it will behave like a super conductor, means more than the conductive effects will be phenomenal, exceptionally high. So in that case, the resistance will become zero. The resistance of that conductor, this conductor coil resistance, will become zero. So in this formula, if the resistance becomes zero, what will happen? The current will become infinite. Okay, so this current will become infinite, means the infinite duration the current will be flowing, no loss in that, and I square or loss or heat loss, thermal loss will be not existing. So means once you filled a current, there will not be any drop in the current. Whatever current you have injected, the same current will flow for a long duration. So same magnetic field will be there, no drop in the magnetic field. So now this black color coil, you can see here that black color coil is sitting inside the liquid, and there are shieldings, 20 Kelvin shielding, 80 Kelvin shielding, and outer vessel, vacuum vessel. These are all different shieldings to protect, to make your liquid much more intact inside the vessel. So this is the diagram. So now another thing I am introducing here is a kind, here you can see this is another structure here I have made. So the outer one is outer shield, outer vacuum shield. Here this area, this entire area is vacuum. Okay, means air is out, there is no air, so heat conduction will not be there, vacuum. Another shield is 80 Kelvin shield. This shield is 20 Kelvin shield. You can see here this shield is 20 Kelvin shield, and the blue color is your helium chamber. So in this helium chamber, some liquid quantity will be there, some gaseous clouds are there, and the innermost will be your, the means to denote in this diagram, means I am trying to project that this black color magnet coil is dipped in the liquid helium. I'll show you one good diagram downloaded from the internet. Just focus on this one. So this black color is a magnet diagram. Here the black structure is a cold head. This is called 10K cold head. Okay, this is 10° inclined from the vertical. There is one reason for the name 10K, and also you can see here that there are stages. One stage is here, another stage is here, and this one is your cold head. Okay, so one stage is connected with this 20 Kelvin shield, another stage is connected with this 80 Kelvin shield. So there are two stages of this cold head. So with the effect of this, one stage 1 is connected with 20K and stage 2 is connected with 80K. So with the effect of this one, this cold head stages, the inner atmosphere stays in 10 Kelvin 10 Kelvin cooling state. Okay, so here is the liquid and some gaseous, so internal chamber will be in 10 Kelvin atmosphere. So what will happen inside? What is the liquid? What is the liquid temperature? 4 Kelvin liquid temperature. Liquid helium is 4 Kelvin. So this cold head maintains 10 Kelvin. So there might be some losses. Okay, from inside out there will be some losses, but that loss is very less. So since this cold head maintains the 10K state inside the vessel, it is called 10K cold head. Okay, and there are two stages. So and this one is your gas line. You can see the compressor here. I'll show you another diagram. This is too much crowded. So here see, this is a cold head. Cold head has two stages, 80 Kelvin and 20 Kelvin stages. This is your cold head. It is inside your MRI machine. This is your gas line and this is your compressor. Some companies sell F70 compressor, some companies have F50 compressors, and so depending on that. So this is your 10K cold head structure. Let us see another full diagram. So after studying all these previous structures, now you can easily understand this diagram. This one I downloaded from Google. See, this is your cold head. Just pay attention to this diagram. This cold head has two different stages. One stage is this and another stage is this one. You can see here. And this one is inclined from vertically inclined 10°. Okay, that's why the term also called as 10K, and also it maintains 10K cooling inside. So inside liquid, this liquid is of 4K temperature. So definitely this is much more cooler. Okay, and this cold head maintains this stage is connected with this shield. This shield is 20 Kelvin shield. Okay, you can see in the diagram also I am drawing parallelly, and this stage is connected with 80 Kelvin shield. 80 Kelvin shield. So because of these two connections, stage 1 and stage 2, the internal atmosphere stays at 10 Kelvin. Okay, so the losses, because the helium is 4 Kelvin state, and also we are establishing a 10K environment here, so the loss will be very less. So this heating will not go out so easily. So this is the basic feature of 10K cold head, that this cold head maintains the 10K environment, so inside out liquid loss is very less. Okay, so that's why we call it as 10K magnets. There are losses in 10K magnets, but loss is very less. So if you see another diagram, this one. So this is your cold head. Stage 1 is connected with one shield, stage 2 is connected with another shield, and this is a gas line here connected with the compressor and further connected with the chiller. Water is going in the compressor and coming back, and this gas line is connected with the cold head, and the gas to and fro motion maintains the stages. This stage will maintain at 20 Kelvin and this stage will maintain at 80 Kelvin. So with the effect of these two, 20 Kelvin and 80 Kelvin, we successfully managed to make this environment at 10K, very cold. So this one is 80 Kelvin stage, this one is 20 Kelvin stage. So because of this and this, somehow we manage here 10K. So because of this 10K, successfully we keep our helium. Here is your helium. We keep our helium intact. And do you know the helium temperature? 4K. So the losses hence reduced because of this cold head. The losses are reduced. Although there is a loss, but very less. So that's why we call it as a 10K magnet technology. Hope I made this thing clear. Actually there are a lot of theories involved. Each and every topic takes so long time to explain. So if you have any question, please write in the comment section and I'll try to answer your questions. I'll make further video. If you like my method, this is a teaching method, this is drawing and writing on the notebooks, please write your comments and give your feedbacks. Thank you very much for your precious time and for watching my videos.